Hello, college algebra. So I know that a lot of you guys had a really tough first week, and week two has a lot of challenges with it as well, just a little bit different. So I did put this announcement out early in the week, and there's a link here to when week two brings us to matrix math. Here's a helpful calculator. So I am going to use that calculator a little bit in this video. I wanted to talk a little bit about the problem set because I think that that's one of the places that you guys um, can use a little bit of help. Can we add any two matrices together? If so, explain why. If not, explain why not, and give two examples that cannot be added. So remember, when we're adding matrices, they have to be the same size. So if it's a 2 by 2 matrix plus a 2 by 2 matrix, we could add the two of them together. If it is a 2 by 2 matrix and we have a 3 by 2 matrix, we cannot add those guys together. So those would be examples that we could and cannot add together. Can we multiply any column matrix and any row matrix? Explain why or why not. So remember, you need to have those that equal row from the second matrix and the equal column from the first. And then is matrix multiplication commutative? And it's not. And prove why it's not. So just give an example of it. Where are some good places that you could do that? You could come in here. So I am going to change this to a 3 by 2 matrix. And I'm going to change this by a 2 by 2 matrix. So this would be a good example if I wanted to say, can I add these? If I tried to add them, it tells me they must be the same size. So that would be an example of why we could not add them. If I try to multiply them, it will multiply them because we have the same number of rows here, the same number of columns here, sorry, and the same number of rows here. If I was to change this to a 2 by 2, I could also multiply those. But if I tried to make him a 3 by 3, it would tell me A's columns must equal B's rows. Therefore, I would not be able to multiply a 2 by 2 and a 3 by 3. So that's just an example of a way to kind of double check yourself, give yourself an example while you're doing those. When we come down here and they want me to add A plus B, A is 1307, so I'm going to come in here. I have 1307, and B is 214.22.6. 826. And I want to add those together. And this tells me it's the matrix 3, 17, 22, 3. The way they got that was 1 plus 2 is 3. So we're adding the pieces in the same spot. 3 plus 14 is 17. 0 plus 22 is 22. 7 plus 6 is 13. So this is a great tool to help you along the way. As far as the subtraction goes, so if I wanted to do B minus E, so B is 214.22.6, so I'm going to cheat a little bit here because, and then it wants me to add that, subtract that, I'm sorry, from E, which is 6, 12, 14, 15. 6, 12, 14, 15. So we are going to subtract those, and we're going to see negative 4, 2, 8, and 9, because we subtract right across. 2 minus 6 is negative 4, 14 minus 12 is 2, 22 minus 14 is 8, and 6 minus 15 is a negative 9. So that's going to be that adding and subtracting piece of it. What we're doing is we're adding where each of the places, each row, each column gets added together. Down here, they wanted me to do a scalar matrix. So in order to do a scalar matrix, I'm really just multiplying the scalar, the term on the outside, by everybody on the inside. Think of it as a distributive law with multiple terms. So for 5 times a, I would have to multiply 5 times 4, which is 20, 5 times 5 times 6, which is 30, 5 times 13, and then 5 times 12. And that would be my new matrix. When they ask me to multiply here, I would want to do what? I have negative 1, 5, 3, 2. And the second matrix here for my B is what? It's a 2 by 3 matrix. And so I'm going to have 3, 6, 4, negative 8, 0, 12. And we want to multiply those, so A times B. So my output matrix here, so we want to make sure that we understand where each of the pieces are coming from. So we would multiply our 1 times 3, which is 3, and add it to 5 times negative 8, which is negative 40. 3 plus a negative 40 is my negative 37. And we would do the same thing. 1 times 6 plus 5 times 0, which equals our 6. 1 times 4 plus 5 times 12, we're going to have 20 plus 60 equal 20 plus 24, which, 1 times 4 is 4, plus 60 is going to be our 64. So as we go through, and then you're going to do the same thing with the 3 and the 2 with each of those columns. And finally, down here, the biggest trick with a squared, they tell you, is a times a. And then this guy wants you to do multiple pieces along the way, so make sure you do those order of operations. So to do 4a, you would have to do 4 times a, and then you're adding it to 5 times d. But one of the things that you're going to notice that is, can that even be done? Because that's going to be a 2 by 2, this is a 3 by 3. Can I even add those guys together? And the answer is going to be no, I can't. But 2 times c plus b, I would multiply 2 times my C matrix and add it to my B matrix. This calculator that I included in that announcement is really helpful. I hope that you guys get to use it. I also want to remind you guys quick of some of the other assignments that we have due this week. So we have that knowledge path assignment, which most of you are doing really well on. A couple of you guys haven't started yet. You really need to get in there. Our week 2 discussion talks about matrices and where they're used. My question for you is going to be, what about your career? When would you use it in the career that you're choosing to go into? And then we also have that quiz again this week. Please reach out to me with any questions you might have.